thermistor is a heat sensitive device whose resistivity is rapidly changes with temperature. Here the temperature coefficient of thermistor may be positive or negative. Here the thermistors are usually prepared from oxides of metals nickel, copper, cobalt and iron, etc. These compounds are the semiconductors. Here the thermistor is very small in size, generally is got from disc or rods. Here the pair of platinum leads are attached to the two ends of a thermistors for electric connection. This device is shielded by the glass tubes. Now the resistance of the thermistors is in the ranges of 0.1 ohm to 10 to the power of 7 ohms. It depends on its composition. The thermistors are over a wide ranges of temperature. Important applications of thermistor. Thermistors are used to detect a small changes of temperatures and to measure the temperatures are very low, that is in the order of 10 kelvins, and a typical thermistors are used to easily measure the change of temperature is very low, that is 10 to the power of minus 3 degrees Celsius. Second application is thermistors are used to safeguard the filament of a picture tube in a television and set against the variation of the current. And thermistors are used to temperature control unit in industry. And thermistors are used to voltage stabilization and remote sensing. Now, superconductors. Professor K. Honors is discovered in 1911. Some materials and alloys lost their resistance at the low temperatures. Almost the resistance will be zero. This phenomenon is known as a superconductivity. As the temperature decreases, the resistance of the materials will be decreases. But at a certain value of temperature, or that is called as a critical temperatures, the resistance of the materials will be disappear. That means the resistance of the materials becomes zero. At low temperatures, the resistance of the materials will be zero. That conductors or that materials are called as a superconductors. Here in the superconductors, without applied EMF, the steady current can be maintained in the superconductors. Now the variation of resistance with temperature that is the it is the resistance and it is the absolute scale, Kelvin scale. Now here, for this is the graph for mercury at 4.2 Kelvin. Below this temperature, the mercury which acts as a superconductor, because of at below 4.2 the resistance of the mercury is abruptly dropped. For the critical temperature of the materials is different for different materials, because it depends on the nature of the materials. For example, for mercury, the critical temperature is 4.2 Kelvin for mercury. For lead 7.25 Kelvins, and for niobium is 9.2 Kelvin. They becomes as a superconductors. Applications of superconductors. Here, the superconductors are used to make a strong electromagnets, for strong electromagnets. Second one is the superconductors are used to very high speed computers, and the superconductors are used to transmit the power, electric power. Now we are going to discuss color code for carbon resistor. Color code for carbon resistors. Now here in market, the commercial resistors are the carbon resistors. These are made by molding carbon into a cylinder with lead wires at the end of the cylinder, like this. It is the cylinder. In the cylinder, which can have a cylinder of the two ends of the cylinder, which can have a two lead wires. Here, these every such a carbon resistors is coated with ceramic and or plastic jockeys. On the value of resistance of the resistors are under the tolerance or percentage of accuracy is printed on the color bands on the resistor, like these first, second and third bands. This is the first band 1, band 2, this is the band 3 or ring 1, ring 3, and the fourth ring. Here this is the fourth ring. This is first band is represented as a digit 1. Second band is represented as a digit 2, and the third band is represented as a multiplier, and fourth band is a tolerance. See, these why we have studied about the color code of carbon resistors means because of these carbon resistors are commercial resistors, and it is very low cost resistors. That's why it is the carbon resistors are with compact, and the carbon resistors are it is widely used in the electronics. That's why we have studied about carbon resistors of color codes. Now here, how to know about the color codes? Now the color codes of resistors. Color code of resistor. Color codes of resistor. Yes, we can understand the table here. Here it is the color, it is the number. We can give the number aid of color of number, and it is the multiplier, and it is the tolerance. See, color, first color is the black, now brown, red, orange, yellow, green, blue, violet, gray, and white, and gold, silver. It is no color finally. See, black number is 1, 0. Brown color is 1. Red color code is 2. Orange color code is 3. Yellow color code is 4. Green color code is 5. Blue color code is 6. Violet color code is 7. Gray color code is 8. White color code is 9. Gold, there is no color codes of these. Now multiplier is a 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, here 10 to the power of 6, 10 to the power of 7, 10 to the power of 8, 10 to the power of 9. For gold, 10 to the power of minus 1, multiplier of silver is 10 to the power of minus 2. This is no color, has nothing. Tolerance for gold only plus or minus 5%. Silver is plus or minus 10%. For the fourth band, it is no color. That is the tolerance of that resistors is 20%. We can't understand someone asking more time, what is tolerance? Tolerance is nothing but the percentage accuracy. Actually, what is the percentage of the accuracy in the finding of resistance? That is the tolerance. Now, by using these, we are calculating about the resistance, the value of resistance of the resistors. Now here, these how to remember, how to remember these about the color codes. It's a very simple to remember it. One line, that is B.B. Roy, Great Britain. B.B. Roy, Great Britain. Very good wife. Great Britain, very good wife, with gold silver necklace. See, gold silver necklace means no color. That is B.B. Roy, Great Britain, very good wife, with gold silver necklace. By using these, we can simply finding about these three are the tolerance. Okay, up to here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is the number order. B.B. Roy, Great Britain, very good wife. Multiplier means 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4. The 10th power of the color code number. We write means we can easily find. Now, for example, one question. Here on the resistor, carbon resistors having the bands are yellow, blue, B-L-U-E, blue, yellow, blue, and red, yellow, blue, red, and silver. The fourth band is the silver, red, silver. This is the yellow. This is the bands on the color on the carbon resistors. Bands on the color bands on the carbon resistors. Find the value of resistance. Very simple. Yellow. Yellow is belongs to what is the first band is the first digit. First band is the first digit. Yellow is the first band. First band is what? The 4. First digit. Yellow color code is 4. Second band is the second digit. Is what? The blue. Blue is belongs to 6. Red. Red is the third band. Third band is a multiplier. Remember it. Third band is a multiplier. 10 to the power of 2. Red is the 2. 2 means 10 to the power of 2. Multiplier. And the silver. Silver is the tolerance. That is the plus or minus what they given 10% of the for silver. This is we can be written as like this also. 4.6 into 10 cubed plus or minus 10%. This is. If the option is there like this, it is correct, or this correct. But another way also they will given in the options for an objective point of view. That is percentage calculation. You see, R is equal to 4.6 into 10 to the power of 3 plus or minus 4.6 into 10 to the power of 3. 10%. What is the meaning of 10 by 100? The percentage of this value. The percentage of this value. That's why we can write like this. Now 4.6 into 10 to the power of 3 plus or minus. Now calculated here. Cancel. That is 0.46. 0.46 into 10 cube. Now we are taking common here. 4.6 plus or minus 0.46 into 10 to the power of 3 ohms. That we write 4.6 plus or minus 0.46 kilo ohms. This is the answer. Maybe option will be here, this, or maybe this or this. Any one is correct based on the options. Now we are going to discuss problems based on color code resistance of a resistors. Only 2 problems is enough for that. First problem, the resistance of given carbon resistor is 2.4 into 10 to the power of 6 plus or minus 5% of 5% ohm. What is the sequence of colors on the strips provided on resistors? What is the sequence of colors on the strip provided on resistor? Now first what they given, we can write the resistance of a carbon resistor R is equal to 2.4 into 10 to the power of 6 plus or minus 5%. They are asking about colors on the strip. This problem we can solve means we can remember that color codes. The simple way to remembering of color codes, that is very simple. That is B. Roy, Great Britain, very good wife, with gold silver necklace, with gold silver necklace. See, B means black. Black means 0. Brown means 1. Red means 2. Orange, yellow, green, blue, violet, grey, white. Here this is for gold, silver, no color. Now multiplier. 10 to the power of 0, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, 10 to the power of 5, 10 to the power of 6, 10 to the power of 7, 10 to the power of 8, 10 to the power of 9, that is 10 to the power of minus 1, 10 to the power of minus 2. For no color, there is no multiplier. These are used to first digit 1 and digit 2. This is 1, digit 2. This is for digit 3. This is a multiplier. And next, the fourth band is the tolerance. For the tolerance is what? Only gold. Gold will be there means 5%. Silver is there means 10% plus or minus 10%. And for no color means plus or minus 20%. This is simple one. B.B. Roy, Great Britain, very good wife with gold silver necklace. Now we see here. First digit is what? 2. Second digit, but point is there. That means we can to remove the point. How? That is R is also can be written as here 10 to the power of 6 is there. Then it is multiplied with 1, 10. That's why what? 2.4 nothing but 24 into 10 to the power of 5. Because multiplied with 10 and divided by 10, then cancel. Simply can be written as 24 into 10 to the power of 5 plus or minus 5%. Here 2 is belongs to first digit. First digit is what? 2. 2 is there. 2 is the color code is red. Next, second digit is 2. Second digit is 4. 4 is yellow. Next, multiplier. Third is the multiplier. Third band is the multiplier. Multiplier is what? 10 to the power of 5. 10 to the power of 5 is green. Now, tolerance 5%. Tolerance means percentage accuracy. That is gold. That is on the strip of colors. Colors on the strip is first color is red, second color is yellow, third color is green, fourth color is the gold. This is the answer. Now we are going to second one. A current of 2 milliamperes is passed through a carbon resistor, color code carbon resistor with first, second and third rings are yellow, green, orange color. What is the voltage drop across the resistor? Same colors is given, finding resistance and find the voltage drop across the resistors. Now here, first what they given, right, 2 milliamperes. Current is 2 into 10 to the power of minus 3 amperes. Now, what is the first and the second, third ring? First ring is yellow. Yellow first ring means the first ring is the first digit. First ring is the first digit. What is the first digit? Yellow. Because of yellow is the first ring. That is first digit is 4. Resistance 4. Second ring is the green. Second ring is green. Green means what is the digit of second green? Color code is 5. That is the second digit. Third ring is represented as a multiplier. That's why what they given? Orange. Orange is the 10 to the power of 3 is the multiplier. 10 to the power of 3 ohms. But here now fourth ring is not given. What we can take? Tolerance is plus or minus 20%. But in this type of problems, we are calculating the voltage drop across the resistors, not need to take in the tolerance. Especially in the problem, in the objective point of view, they mentioned up to the tolerance, the value is mentioned means we will take. but not need to this problem. Now that is we know that R and I, according to the Ohm's formula, V is equal to potential across the resistor, V is equal to IR. V is equal to I is 2 into 10 to the power of minus 3. R is 45 into 10 to the power of 3. Then cancel. V is equal to 45 2s are 90. 90 volt is the potential drop across the resistors is 90 volt.